Hi, this is Dr. J. Vikas Paul. In this session, we'll discuss about the continuous beam problem. Analyze the continuous beam as shown in the figure by using three-moment theorem, three-moment equation, and draw the BMD. So you can see the continuous beam here. At A, it is fixed support. At B, it is roller support. At C, there is a roller support. And for span AB, on span AB, you have 20 kilonewton per meter UDL, and I value is 2I. And for BC, I value is I. Okay, the span is, for AB it is 6 meter and BC is 4 meters. Now, in the analysis of continuous beams, the first step is assume as simply supported beam and draw bending moment diagram. So, assume the given beam as simply supported beam means remove the fixed support A and put simple support, and at B and C already they are simply supported only. So, convert it into simply supported continuous beam and draw BMD. This is the first step. Since the given beam, continuous beam is fixed at support A, an imaginary zero span is to be taken to the left of support A. So as there is fixed support there in the given beam, we need to draw an imaginary line A0A of length L0 equal to 0 meter and no load is there on A0A. Why we are drawing like this? Because here in this question we need to find MA and MB. MC is anyhow 0 because it is simply support. We need to find MB and MA because fixed support is there, therefore MA we need to find, and intermediate support is B, therefore MB we need to find. There are two unknowns, MA and MB. So we need to apply three moment theorem 2 times. So for that we are taking this imaginary line. So that we can apply three moment theorem 2 times, that is A0 for A0 AB and second time for ABC, and we can find MA and MB. Okay, now you can see the figure here. For span A0A, bending moment is 0 as there is no load. For span AB, maximum bending moment is, so now we are drawing free bending moment diagram here. Okay, for span AB, the maximum bending moment is WL square by 8, so 20 into 6 square by 8 equal to 90 kN per meter. And for BC, bending moment at E is WL by 4, 40 into 4 by 4, 40 kN per meter. So MD is 90 kN per meter, ME is 40 kN per meter. Now in the second step, we need to calculate area and centroids for the free bending moment diagram. So for A0A, if I calculate the area and centroid distances, A0 is equal to 0 because there is no load at all and no area is 0. Now x0 bar left is equal to 0 and x0 bar right is equal to 0. Next, coming to the other span AB, area is A1. Okay, now area of parabola is 2 by 3 times B into H, which is equal to 2 by 3 into 6 into 90, 360 meters square. Now for AB span, x1 bar left is equal to L by 2. So span of AB is 6, so 6 by 2, 3 meters. x1 bar right is equal to L by 2 equal to 3 meters, 6 by 2 equal to 3 meters. So now coming to BC span, area of free bending moment diagram is half into B into H, area of triangle. So half into 4 into 40, 80 meters square. Now x2 bar left is equal to L by 2, 4 by 2 equal to 2 meters, x2 bar right equal to 2 meters. So here we are getting x left and x right same because it is symmetry here. Now coming to step 3, apply three moment theorem. So 2 times we need to apply, as I said, A0 for A0 AB and ABC. Now first we will apply for A0 AB. So according to the formula we need to apply. So M0 into L0 by I0 plus 2MA L0 by I0 plus L1 by I1 plus MB into L1 by I1 equal to minus 6 A0 X0 bar left by L0 I0 plus 6 A1 X1 bar right divided by L1 I1. Okay, so M0 is 0, so 0, L0 is 0, L0, so 0, we are substituting here. So simplify again, here it is becoming 0 right side, A0 X0 bar. Okay, so simplifying this, we will get first equation 6MA plus 3MB equal to minus 40, and similarly let us apply three moment theorem for ABC. We will get MA L1 by I1 plus 2, MB L1 by I1 plus L2 by I2 plus MC L2 by I2 equal to minus 6, A1 X1 bar left by L1 I1 plus 6 A2 X2 bar right divided by L2 I2. Okay, now substituting MC equal to 0, MC equal to 0 as it has simply supported C. Okay, Then we will get this equation simply after simplification 3ma plus 14mb equal to minus 780. Let this be equation number 2. Now let us solve equation 1 and 2. We can find ma and mb values. So we'll get ma as minus 69.6 kilonewton meter, mb as minus 40.8 kilonewton meter. Okay, negative indicates hogging moments. Next, step 4, calculate the reactions. So how to calculate reactions? Now draw this simply supported beam, continuous beam, and draw AB separately and BC separately. Okay, at B you divide it as B1, B2. Means first span is A, B1, second one is B2C. For AB1, show the moments and reactions. Okay, reactions will be RA at A, and at B1 it will be RB1. And moment at A is already we have found now minus 69.6, so 69.6 anti-clockwise, so minus. And at B you should indicate like this, B1, okay, to the clockwise, and B2 again anti-clockwise. Okay, now we need to apply the loads also applied, and RA, RB. So for these two spans separately we need to find the reactions. Okay, now for the first case we will find RA and RB1. How we will find? Using a sigma Fy equal to 0 and applying sigma moment about B1 equal to 0. Okay, by applying these two equilibrium equations we can find RA. So RA will get as 6.48 and RB1 will get as 55.2. Next, coming to the second case, point load. So here RB2 and RC we need to find. Applying sigma Fy equal to 0 and sigma moment about B2 is equal to 0, we can find these values. We will get RC as 9.8 kilonewton, RB2 as 30.2 kilonewton. Now RB, total RB is equal to RB1 plus RB2. So RB equal to 55.2 plus 30.2, 85.4, RA is 64.8, RB is 85.4, RC is 9.8. So we can draw the shear force diagram. So it will come in this way, SFD. And bending moment diagram, first of all we need to draw for a free bending moment diagram. Already we have drawn the same thing, and then in that we have to include the MA, MB, MC values. So MA 69.6 we need to draw upwards, and MB also upwards, and MC is anyhow 0, so we need to join the lines, and you should indicate minus plus net bending moment diagram. Okay, this is the final bending moment diagram. This is how we will analyze the continuous beam using 3-moment theorem. In the same way, we will see the other problem. A continuous beam ABCD simply supported at A, B, C and D is loaded as shown in the figure. You have point loads on AB and BC, and on CD you have UDL spans are shown in the figure. So calculate moments and the beams, draw SFD, BMD. So for here we need to calculate MB and MC. That's it. MA is anyhow 0, MD is anyhow 0 because there are simple supports. So MB, MC we need to find out. So using the 3-moment theorem. So 2 times we will apply here for ABC 1 time and BCD 2nd time. So first step, draw the free bending moment diagram for the given beam. Okay, so free bending moment diagram we need to draw. Already it is free bending moment. All the supports are simply support. So let us draw BMD for this case. Okay, so if we draw BMD, first of all, for AB and BC and CD we need to calculate the maximum bending moment values. Okay, so for span AB the length is 6 meters, A1 is 2 meters, B1 is 3 meters. Okay, for span BC L2 is 5 meter, A2 is 2 meters, B2 is 3 meters. For span CD L3 is 4 meters. Okay, it is symmetry load on CD. Okay, so B and C supports are intermediate and supports. So intermediate supports as a fixed end supports act as fixed end supports. So MA is equal to 0, MD equal to 0, MB is not equal to 0, MC is not equal to 0. We need to find MB and MC values. Now we can calculate the maximum bending moment values. For AB, it is WAB by L, so 9 to 24 by 6, it is 12 kilonewton meter. And then for next span BC, it is 9.6 kilonewton meter, same formula, WAB by L. But here the ABL values are different, okay, for BC. Next, for CD span, it is UDL, so the maximum element formula is W square by 8. So 3 into 4 square by 8, it is 6 km per meter. So we have to draw the bending moment diagram. So this is your free bending moment diagram. Okay, now coming to step 2, calculate area and centroids for the free bending moment diagram. So first of all, let us calculate A1, that is area of AB. Okay, bending moment diagram. So half into B into H, it is 36. Next A2, half into B into H, it is half into 5 into 9.6, it is 24. Next 2 by 3 BH for CD. Next, so it is A3 is 16. Now X1 left, observe carefully, X1 left means for AB span, X1 left equal to L1 plus A1 by 3. The formula is centroid formula. So 6 plus A1 is 2. 6 plus 2 by 3. Okay. Next 8 by 3. Next X1 bar right, the formula is centroid formula is L1 plus B1 by 3. Here L1 is 6, B1 is 4. So 6 plus 4 by 3, 10 by 3. Okay. Similarly for A2, for BC span, X2 left is equal to L2 plus A2 by 3. It is 5 plus 2 by 3, 7 by 3. X2 right, it is L2 plus B2 by 3. It is 5 plus 3 by 3, 8 by 3. Similarly for A3, for CD, X2 left equal to X3 right equal to L by 2, that is 4 by 2, because it is symmetric load is there. Okay, it is 2 meters. So X2 left equal to X3 left right equal to X3 left equal to X3 right equal to 2 meters. Next, step 3 is apply Clapeyron's theorem, 3 moment theorem. First we will apply for ABC, then we will apply for BCD. So if we apply for ABC, this is the formula. MA L1 plus 2 MB L1 plus L2 plus MC L2 equal to minus 6 into X1 by L1 plus A2 X2 by L2. So in this problem, I1 equal to I2 equal to I3. Only I is there. Okay, no different moment of inertia are there. Only I. So this formula directly we can apply. Okay. So we know that MA equal to 0. So instead of MA, we substitute 0. Okay, instead of A1 X1 bar left, we'll substitute 36 into 8 by 3. And instead of A2 X2 bar right, we'll substitute 24 plus 8 by 3. Okay, then we'll get, on simplifying, we'll get 22 MB plus F5 MC equal to minus 172.8. Let this be equation number 1. Next, for BCD, let us apply 3 moment theorem. So MB L2 plus 2MC into L2 plus L3 plus MD L3 equal to minus 6 into A2 X2 left by L2 plus A3 X3 right by L3. So MD equal to 0, we know. So in place of MD, substitute 0. So in place of A2 X2 left, substitute 24 into 7 by 3. In place of A3 X3 right, substitute 16 into 2 divided by 4. Okay, so we'll get 5 MB plus 18 MC equal to minus 115.2. Let it be equation 2. So solving 1 and 2, we'll get MB equal to minus 6.83, MC equal to 4 minus 4.502. Okay, next calculate step 4, calculate reactions. So make it separate, AB separately, draw AB separately, BC separately, CD separately. Next, let us see AB. Here I am writing AB1. Okay, A and B1. B I am taking as B1 here for AB. Now I have to show the reactions RA1, RA, at B1 it is RB1, and at the center it is E, no? Okay. Next, moment, here I am showing it as clockwise. So the value, MB value is 6.83, so I am showing it clockwise here. So applying sigma Fy equal to 0 and sigma moment about B1 equal to 0, we can find RA and RB1. So we'll get RP1 as 4.14, RA as 4.86. Next, coming to BC span. So RB2 is reaction at B2. At C it is RC1. It is C1. Okay. RC1 we need to find. RB2 we need to find. Okay. And I have shown the load here. And at B2 I have shown MB value 6.85. At C1 I have shown MC value 4.502. Okay. Right. So applying sigma Fy equal to 0 and applying sigma moment about B2 equal to 0, I can find the values of RC1 and RB2. So RC1 I'll get it as 2.73, RB2 I'll get it as 5.26 kilonewton. So here we'll get RC1 as 7.13 and RB2 as 4.8. Okay. Now finally we'll get RA as 4.86, RB1 as 4.14, RB2 as 5.26, RC1 2.73, RCD equal to 7.13. Okay, so RB here equal to RB1 plus RB2, which is equal to 9.4, RC equal to RC1 plus RC2, that is 9.86. Okay, So now shear force diagram. So after getting all the reactions, draw this figure and show the reactions and draw the shear force diagram. We know how to calculate the shear force values. So after calculating shear force values, draw the shear force diagram and BMD. First draw free bending moment diagram and then include the MB/MC values. Okay, MB 6.83, MC 4.502, MD 0. So join this line and include. This is the final net bending moment diagram. Okay, thank you.